So when it comes to making the substrate for your Winogradsky column, you're going to need to use mud or a mixture of mud and sand. It doesn't really matter. Try to locate somewhere to sample your mud. It could be at the side of a river like this, or a pond or a stream. Try to, wherever you go, make sure it's safe. Make sure you come with an adult and that you get help. You can also, if you can't get access to somewhere like this, you can also just use soil and a mixture of tap water. But here what I've been doing is I've been gathering mud and sand from along the bank here. You can see it's a kind of dark, quite smelly mud, which is a good sign. Doesn't have to be, and I'm just collecting it here in a bucket here as well. And then the other thing you need to do, if you can, this isn't essential, is just gather a little bit of water from wherever you're gathering your mud from. So I'm just going to gather a little bit of the river water here in a little bottle. I'm going to use this to top up the Winogradsky column. Okay. That should be more than enough, because we'll only use a bottle around about this size, or a jar, to actually make the column in. Okay, and just pop that in my bucket and we're all done. We can go back to the lab. So we're back at the lab, which in this instance is my kitchen, and we're ready to put together the Winogradsky column. Okay, so I've opted to use a glass jar, which is actually an old coffee jar. You can use a jar of any kind of size really, or you can use a plastic bottle. Actually, you could use a bottle like this, would be perfect. Just if you use a plastic bottle, you can cut off the top carefully, and that'll help you whenever you're adding all of this muddy goo in. Okay, so what do we need to do first? And there will be written instructions, a written sort of method for this that you will get as well, to help you put this together. So the first thing we need to do is I've decanted some of the mud that we collected earlier in the day, and I've just tried to lift out any of the bigger kind of roots or any kind of vegetable matter in there. It doesn't matter if there's a little bit, but we want to try and get rid of some of the bigger stuff. And I've also tried to get rid of any of the bigger stones again. You know, if there are a few little ones in there, don't sweat it, but I'm trying to get rid of some of the bigger ones. So the microbes that are in here, basically what we're going to do in the Winogradsky column, it's just a way for us to culture and to grow those microbial communities, and to see how they grow, and particularly how they separate, right, vertically within the soil. And you should see that for yourself as the experiment proceeds on your shelf. So the first thing we've got to do is we've got to give this microbial community a little bit of a nutrient boost to start off. We've got to give it some food. And so I'm going to take a little bit of the mud here, and I'm going to pop it in here. Let's not take all this root stuff, okay? I'm going to pop, and this is sort of, your mud may be finer. This is a little sandy because we took it from the edge of a river, and that's just where it was handy for me. You may have different mud, okay? And I'm just going to mix that with a little bit of the this is from the river that we sampled before, and basically I'm just going to make a kind of paste. It doesn't really matter what the thickness of that is, but I guess like about the consistency of a milkshake is what you're looking for. Okay, now we got to add some nutrients. So most of the microbes that will be present here, that will grow hopefully in our column, they're going to rely on two main nutrients, two main elements: carbon and sulfur. Now for carbon, we're going to add carbon in two forms. Okay, we're going to just add carbon in the form of sort of organic matter, which we're going to proxy with newspaper clippings. Okay, so just add that into this little pile of goo. And we're also going to add just a little bit of, this is just eggshell. And this just is a different kind of carbon. It's carbon in the form of the mineral carbonate, which you may have heard of. It's just a different form of carbon and a different way for the bacteria and the microorganisms to get at that carbon. And the other thing we're going to add is a source of sulfur, the element sulfur. And a great source of sulfur is just simple egg yolk. Okay, so I'm just going to add one separated egg yolk in there. Right, now this is the fun bit. So we're just going to mix this up and form a bit of a gooey, mucky, messy, nasty paste. Okay, just like this. Okay, and it goes. Cool. Okay, so that's now looking fairly well mixed. Okay, so this is going to be sitting at the base of our column, right? And it's starting to stick, which is good. That's good for us. And we don't need this stone. Let's get rid of that. Okay, so I'm just going to scoop this now into the base of the column. All right, and again, I'm using a jar. You can use whatever's available and works for you. I'm also protecting my kitchen table with some kitchen paper. It's up to you whether you choose to do that. Okay, and it goes. It's a bit messy, but we can clean it up later. Yeah. And goes all that lovely eggy, carbony goo. Okay, so this looks absolutely vile, but this is a banquet for the little microbes. Okay, and now we're just going to add a little bit more muddy earth to just fill up our column a little bit more. Okay, so just slop some goo in there, trying to avoid getting, and if there are some like roots or material in there, don't worry too much about that. Ultimately that's just another source of carbon. It's going to decant a little bit of water at the top. Don't drink that. Okay, top up a bit more, top it off a little bit more. I know it's smelly, isn't it? It's smelly, and that means hopefully this will work. Means it's hopefully full of bacteria. We can't see them yet, but if we culture them, like a scientist called Winogradsky, that's the Winogradsky column is named after. He was the one that invented this method of growing microbial communities so that we could see them. Okay, right, so got a good kind of substrate here. Just a little bit more, if we can get it topped up a little bit more. Okay, cool. And this is a science experiment, which is the fun bit. So we don't know what's going to happen now. So that's cool. And then I'm going to top the top of the column off with a little bit of the river water, which also stinks. So we can add that in like this on the top. Okay. Now it's a little bit murky. So one of the first things I'm going to predict, right? As someone that studies sand and mud and rocks in water systems, is that all of that's going to settle down now overnight, and we're going to be left with a much lighter water column. So let's clean it down, but you can already see that the surface of the sediment is about here, and then we've got a body of water. So it's cloudy now. All that fine grained sand and silt, that's going to settle out overnight, and we're going to end up with hopefully a nice clear water column on top of our sediment pile. And you can see in there, hopefully you can see bits of the newspaper, maybe a little bit of eggshell. The egg yolk is all mixed through. So we've got a nutrient-rich sediment which contains two sources of carbon and a source of sulfur. Now, the other thing that we have to do just to finish this off and to make sure that we're growing our microbes in the right kind of setting, is we've got to seal it off from the atmosphere. So I've got here just a bit of cling film, which I've already cut, and I'm just going to use that to seal off the system, get a nice tight seal around the top. You can see that that's now all cut off from the atmosphere in this room. And this makes it a closed system. So that means that anything that the microbes are going to eat, microbes just being another word for microorganisms, okay? Anything that those microbes are going to eat is already in there, or they're going to eat something made by another bunch of microbes. And that's how those communities, well, we'll see how those communities change and evolve, okay? So that's it really. What I would recommend you do now is leave this somewhere for a while, okay? Microbes take a little while to grow and establish. So we can leave that in a well-lit area. I wouldn't leave it in direct sunlight because it might dry. And just see what happens, and keep an eye on your cling film, keep an eye for any evidence of any gas production. That's a hint as to what you might want to look for, and then look to see how that sediment changes, how the water changes, and whether you can see any signs of life. So I'm going to leave this now for a while, and the next you hear from me will be a bit in the future, and we will see how our Winogradsky column for growing microbes and growing bacteria, how that has worked out. All right, see you then. Okay, welcome back guys. So it's been 8 days since we built our Winogradsky column, and so it's time to check in and see what's been happening in the intervening time. So I'm just going to use a torch to illuminate things here. So you can see in the sediment here, not an awful lot has changed that we can see, but I've actually had to add an extra wrapper here because guys, this was getting really stinky and there's a real bad smell coming from this jar. And that's because in the sediment here somewhere, we're producing hydrogen sulfide gas, okay? And you might know that gas more commonly referred to as rotten egg gas, okay? Because it smells like rotten eggs, really sulfury, kind of horrible smell. And that's coming from within the sediment pile from the breakdown of, by microbial breakdown of those newspaper cuttings and of the egg yolk, right? Okay, so that's what's happening in there. So we can't see much, but we can smell it. Now in the water column, there's been an awful lot more activity. You can see there's a sort of whitey layer at the bottom here. Now for a few days, 3 or 4 days after we built the column, the white layer was floating at the top. I don't really know what that was, but it's since sunk back down. And the column has turned this greeny blue color. And that's probably telling us about the presence of blue-green algae and also cyanobacteria. And there's hints too that these guys are living and making oxygen through photosynthesis, because if we just look at the top of the column here, you can see all of these air bubbles on the top. And the top has formed a kind of film, we call that a biofilm. And that's where there's an awful lot of activity happening, and you can see those bubbles within the fluid, probably of oxygen. So you have this is kind of an indication of what's happening. It's in the handout that goes along with this. Oxygen production at the top, and that's creating an oxygen gradient down through the column. Hydrogen sulfide production at the bottom, and that's creating a gradient up through. And so different microbes are finding their space from the top, oxygen-rich top, and the hydrogen sulfide-rich bottom. They're finding a place that works for them. So I'm just going to keep this running, guys, for, I don't know, weeks, months, however long, before it gets too smelly, and just see how many different microbial communities grow and flourish, and what kind of colors and all kinds of exciting stuff that we can see in this column. But I wanted to just show you how it's working and how yours might look after a bit of time. So good luck and happy microbe growing.